All right, now that we know our parallel and perpendicular line equations, we know their slopes, we know all this information about them, let us now take one equation given to us and write the other equation for a line that is parallel or perpendicular to that first equation, given a point that second one needs to go through. So I have listed for you some steps up at the top, and what I'm going to do is I'm going to go over one of the examples, going through each step by step, okay? So here's an example that you're going to be given. Write the equation in slope-intercept form of a line parallel to the given line that contains the given point. So this is what you're going to see. These are going to be your directions. It's either going to say parallel or perpendicular, and then it's going to give you your equation. So here it's y equals 3 over 4x minus 1. And then it says that second line needs to be parallel to that first one and go through 8, negative 2. So we're going to use this information to write that second equation. So step 1 is identify the slope, or the m, of the original equation. So this original equation was given to us in slope-intercept form. So that means our slope is everything in front of the x. So we're determining it from that, which is 3 over 4. So original slope is 3 over 4. Okay, second step is determine the slope of the new line. So this is where we need to go back to the problem. What's it asking us for? Parallel or perpendicular? Well, it's asking us for parallel. So our slopes need to be the exact same. So that means that our slope for our new line is also going to be 3 over 4. Easy peasy so far, using the new slope and the given point. We're going to fill in our point slope form. Do you remember point slope form? Probably not. This is already written in your notes, but you might want to make some notes around it. So our point slope form is y minus y1. That means y from the point equals m slope times x minus x1. Remember, x1 is from the point. So let's fill in our information that we have given to us. We know the slope, and we have a point that we can put into x1 and y1. So y minus negative 2 equals 3 over 4 times x minus 8. So I like to write it like this so that my signs and my numbers don't get all jumbled up. The form is y minus y1. So y minus negative 2, because my y1 is negative 2. Okay, so now I can work this out to put it into slope-intercept form. And the first thing we want to do, that's where we got y1 and y2 from. You might want to label that on your problems. Is step number 4, let's distribute so that we get rid of those parentheses. So whenever I do that, I multiply the 3/4 by both the x and that other number, and I get 3x minus 6 when I do the math. You know how to do this. That's why I'm not going over it in detail. That y minus negative 2, I now have changed to y plus 2 because we know that it's going to be y plus 2. All right, keep going. We need to get y by itself. So that final step says to add or subtract to get y by itself. So we need to move that 2 over to the other side. How do I do that? Subtract both sides by 2, and we get y equals 3 over 4x minus 8. That is our answer. This is the equation of the line that's going to be parallel to that original line going through 8, negative 2. You don't believe me? Graph it. Okay? So you're going to be asked to do this. Remember our our perpendicular lines are going to have different slopes. So this one was easy because we did parallel lines and they were the same slope. Perpendicular lines, you have to do the opposite, change the sign, and flip your fraction. Let me know when you have questions.